Yes, tonight's topic we're looking at rock layers, but I have a bit of biology to start with. Well, it is actually about fossils because people insist that fossils in different layers of rock show us the theory of show us the history of evolution. So if you go to museums, you will usually get pictures of different fossils all lined up, and they say this one evolved into that one because it's found in a different rock layer. And that's what they're teaching at universities these days. And one of our colleagues sent us some illustrations from a recent university lecture on evidence for evolution. And one of them was about whales. Well, a few years ago, I went to the London Natural History Museum, and they had a display about whales. So I thought we could talk about whales. So in this university lecture from this year, actually, was all about the evidence for evolution, and one of the topics was fossil evidence. The fossil record links extinct and extant species. Now, extant is just a posh word for living. Okay, so extinct are dead creatures, extant are live creatures. And then in the same graphic, they had this quote: fossilized hind leg bones link living whales with land-dwelling ancestors. Now, notice the word there, link. What they're saying is that fossil whales that used to have legs are directly linked with the whales that we have these days, and the fossil whales used to live on land. And I remember this was the same story that was in the Natural History Museum. And they gave these examples, these 4 examples in the university notes that we were sent. Right, Pachycetus, terrestrial, these are their words, right? That means land dwelling. Rhodocetus, and that's how they spelt it, predominantly aquatic. Durodon and Baleen, and they identified Baleen as a recent whale ancestor, but in fact Baleen are still alive today. So let's go and have a look at all of those things and see whether they really show a transition from one to the other, and there's a point to be made at the end there. So this is Pachycetus at the Natural History Museum. Now, if you looked at a creature like that on its own, what would you say about it? Why would you think that that was a whale? And in fact, the paleontologist who found the specimen that this cast is based on, and it was actually quite a good specimen in terms that a lot of the skeleton was there. It wasn't just a few fragments. He made this comment in one of the news reports about it back in 2001 when it was first reported in the scientific news. He said, everyone will agree that these creatures are whales. Now, do you agree that that's a whale? All right. Why would he say that? Okay, the reason is because this is a quote from the news source, which we wrote about in our fact file, so you can look up the details of this. They have several strange bones in their ears that only occur in whales. And in fact, what they have is an ear structure that enhances what's called bone conduction. That's vibrations in the skull, which are then transmitted to your ears. And but it turns out that burrowing animals also have enhanced bone conduction, so it's not actually unique to whales. But anyway, going back to our transition, so that's where they've started the whale story. There is supposedly a transition from Pachycetus to a creature called Rhodocetus, and that is the transition from land to water. Now, the Natural History Museum didn't have much to say about Rhodocetus because even though it looks like a semi-aquatic creature, it's not considered to be on the direct line from terrestrial creatures to whales these days. So in fact, this so-called modern university lecture is actually out of date. The main scientist who studied Rhodocetus actually admitted that this is a semi-aquatic creature, but it doesn't have the features that you would expect to find in a whale, mainly in its tail. But anyway, we're looking at leg bones, and they did actually find some leg bones of Rhodocetus. They weren't on display at the Natural History Museum. This is from the Field Museum of Natural History in Chicago. And sure enough, this thing does have hip bones connected to its spine, and it has leg bones. But there are lots of semi-aquatic creatures that still have legs and still have their hip bones connected to their spine, and there's no sign that they are turning into whales. They are just well-designed semi-aquatic creatures that are well designed to swim. Anyway, the next step was this creature, Dorodon, which was in the Natural History Museum because it's considered to be part of the step going to modern whales. And it does have some tiny little bones in its pelvic region. Now, this is the way they had it mounted. It was in a diving position. It was very hard to see these, but if you looked up in the rafters, you could see there were some tiny little bones. And then the next step was Ballina. And now these are actually alive today. They are called bowhead whales, and they do have some little bones again in their pelvic region, but not connected to their spine. So they're not used for walking. In fact, they don't even project from their body. They are actually stabilizers for their pelvic organs. And you can actually see these in modern day whales. But I want to go back to this whole idea of transition, because transition is an active process. So you are never going to see it in the fossil record, even if you have different creatures in different layers, and you can line them up in a sort of succession from a full leg to to what looks like the remains of a leg. No one has actually seen that happen. Now, what I mean by transition is it is an active process, and there's no proof unless it's observed. So we do observe some quite huge transitions in biology. For example, a tadpole to a frog, that's a huge transition, but you can actually watch that happen. But in the next generation, it just goes back to the same cycle. Right. Has anyone seen this sort of transition from Pachycetus to Rhodocetus to Dorodon to Ballina? And the answer is no. No one has seen any of those creatures change. All we've got are the individual specimens that are buried. And the fact that they are in different rock layers doesn't mean that one has turned into another. They are all dead. All of our observations on fossils are that they are all dead. So they are not doing anything. And the fact that we can line them up in what looks like a sequence to us is just a way of explaining or organizing our knowledge. And that's what we've done in biology and in geology. The evolutionists have taken over what is quite a good classification system. In other words, how to organize our knowledge so that we can remember it and build on it. And they have turned it into an active process which no one has actually observed.